Okay, this here is photoanatomy and phototransduction 3. We're looking here at light adaptation and dark adaptation. I've included a good video I just watched that I thought you might glance at, and it goes through a lot of everything, including this light and dark adaptation. But anyway, let's go into this. Okay, here's the scenario. You are in a movie theater, and it's somewhat dark, but not completely dark, or you wouldn't see the movie. And you're coming out of that into bright light. So you're leaving the theater midday, let's say 3 p.m., midday, no rain, bright light. So what will happen then is you have a light adaptation. Now, in the darkness, both the rods and cones are strongly stimulated when you go to the light from the darkness. Now, in the near darkness, the rods were active and the cones were not, because cones need bright light. Rods deal with dead light, low light. The pupils are in this dark environment. The pupils are dilated. Now, remember, this is light adaptation here. So you're in the darkness. In the darkness, let's say a low light, the rods are active because they look at low light, and the cones are not. The pupils, though, are dilated. Okay, they're dilated. Okay. Now, the other thing that's happened is in the darkness, the photopigments, the pigments for the cones, are ready to go, but they're not going because of the fact it's in low light. And the rod's pigments are some bleached, but a lot not bleached because it's very dim light, but it's still some light. All right, so now we go into the light. What happens? A bright light comes straight out. Both the rods and cones become strongly stimulated right off the bat. Okay, the rods become stimulated, but they get bleached now. They're getting bleached totally. In other words, they're not returning to the active form because they're being bleached. The cones have been hit with a lot of light, so suddenly you get this glare. They have to have time to desensitize somewhat. The pupils start to constrict in this bright to take the glare away. Large amounts of pigment broken down instantaneously because of this light, because you're bleaching everything. Visual acuity improves over 5 to 10 minutes, and that visual acuity is because the cones are turning on and the rods are turning off. The retinal sensitivity decreases because it's being stimulated so much. Light adaptation. Dark adaptation. So now I'm going from the outside going into the movie theater, dark movie theater. You move from bright light into darkness. Cones stop functioning in low intensity light. The rod pigments are bleached. The system turned off. Okay. The system was turned off. Now the rods need to turn back on. Rhodopsin accumulates in the dark. Transduction returns to the outer segments, and the pupils dilate. Retinal sensitivity increases within 20 to 30 minutes when, in other words, the rods can be reactivated. Again, a good movie to look at is this here, light dark. Okay. Here we looked at nyctophobia, commonly caused by vitamin A deficiency, a rod degeneration, okay, night blindness, can't see good at night. Vitamin A deficiency is administered early. Vitamin A can restore function. Sometimes also called retinitis pigmentosa that can occur. This retinitis pigmentosa, the rods cannot adequately regenerate, the tips are just start to slough off. Most commonly, though, it's a vitamin A deficiency. For both of these, you're going to be unable to see adequately in dark light. Okay, we'll close here.